Hello and welcome to yet another one of these videos. In this situation, I want to introduce you to a few new data structures which are useful and something about how to use them. I want to do a bit of reminding. Let's just go play 60 and see what we get. Okay, and of course we can see for 0.25 and then play 72. Okay, so that's like the very first movie I did. I just want to remind you that we can use variables to store the things that we play, and we can have expressions. I'm going to make that slightly longer. We can have expressions using variables which actually calculate the number that in this case is going to be played. So note is 60. The first one is just play note. There's a little rule here I use for teaching this sort of thing. If we use the name of a variable and we created a variable up here, then it's the same as if we use the number that's stored in it. Here we have an expression. So again, if we use the name of the variable, it's the same as if we use the number stored in it. At this point, note will include 60. 60 plus 7 is 67. And this whole expression evaluates to 67. And that is the note that is played. Okay, I can of course change the value of note with an assignment statement. We can then quickly desk check this code. Here we create a variable with value 60. We play back 60, which is middle C. Sleep for 0.5. Note equals note plus 5. That's an assignment statement. We calculate the value of the expression here. Note currently has 60. 60 plus 5 is 65. And once we've calculated the value of that expression as 65, we put it into the variable, change the value of the variable. It's now 65. Down here we have note plus 7. 65 plus 7 is 72, which is now a whole octave above the note that we previously played. I think you can hear it's now an octave. Right, let's simplify this right down and just remind you, I like doing bits of revision occasionally, of arrays. If I assign, let's go right back actually. If I say play 60, then it just plays 60. If I want to sort of bundle up different numbers into one single thing, then I can sort of put them into square brackets, put commas in between them, and this whole thing is an array. It's a bit of data which has 3 different values stored in it. If we tell play to play this array, this is what we get. We get a chord. Again, I can use a variable to store it and play notes. I'm going to put this into a slight loop. Okay, that will not sound very exciting. And we'll make it slightly more exciting by choosing a number. So, notes.choose, what does that do? Notes is my array, which stores 3 values. Notes.choose is going to choose a value from there, randomly. So it might be 60, it might be 64, it might be 67. It will choose one of those notes randomly, and that's what will be played. So from an array which has multiple values, we choose a single value. And one way of doing that is to say notes.choose. Let's play that and see what it sounds like. And it sounds quite melodic, as you'd expect, because it's a major chord, simple major chord. Choose only notes from a major chord, and it's going to sound quite melodic. Now, I chose a C major chord there, based on C4, but we're going to sort of take things a little bit further now. I'm going to do something which initially won't work. Okay, something that initially won't work. I'm going to do this. 8.timesDo, not notes.choose, but something called notes.look. And I'm going to put the word tick here. And let's see what this does. So I'm going to play it, and what do I get? Okay. 8.timesDo, and I got 3 notes. And then it stopped and didn't seem to do anything. Okay, what's happening here? Well, fundamentally what this does is that if I'm in a loop or something like that, and I have an array, my code sort of knows where it's up to in that array. It first plays the note 60, then 64, then 67, and then runs out of notes. If we look at the feedback over here as to what was happening, after we got to the end of the array, it just started playing rests. So it did actually play 8 notes, except a lot of them were rests. It played the first one, the second one, the third one. Okay, so again we get that. Now, tick says if we're at the beginning of the array, move on to the next one. So every time we go through here, we move on to the next one in the array, and it knows where we're up to. And if we say play notes.look, that says take the current one from the array. And this is all built into SonicPy, and therefore works easily with no effort for us. It gets a bit boring though if we basically get to the end and it's all rests. An array is one type of data structure. We can have another type of data structure, which is called a ring. And a ring stands for a ring buffer. And the concept of a ring buffer is that even though this ring buffer only has 3 notes in it, the computer treats it as if it goes on forever. So 60, 64, 67, move on, we get back to a 60. We go back to the start, 64, 67, get back to a 60, 64, 67, etc. If we manage to go backwards, which we can't yet, but we'll be able to soon, then we'd actually find that it considers that the numbers extend out this way into negativity as well. So let's see how this works. Okay, so it played 8 notes, and as you saw, if we got to the end, then it went back to the start again. Okay, so that's the basic concept of a ring buffer, and they have far and much more interesting applications than what I've just shown you here. If I want a major chord like this as a ring, there are actually some shortcuts I can do. To make a ring, I could actually put the note numbers if I want to sit there and work them out. But I can do this. If I go chord, and I choose a bass note for my chord, which will be C4, and I give it a type of chord, and I'm going to choose major. Okay, that should give me exactly what it gave me before. And I'm actually going to put a print statement in here to print out the notes and see what we get. And it's exactly the same as it was before. If we find the beginning of our run, it printed out ring 64, 60, 64, 67. That was exactly what I had before, but it's slightly more readable to say this is going to be a chord, and we can start playing around with this. For example, if I go num octaves, then this says to make a chord, but instead of just having 1 octave of chord, it's going to keep on going up. Let's see what we get with that. Okay, so if we look at it, it had many more notes. It had 2 octaves worth of notes, 60, 64, 67, jump up an octave, 72, 76, 79. And there are all sorts of other things we can do. We can play around with this and make it a major 7th chord. And I'm going to make that go through 12 times now. Okay, and that again helps us because we can make these rings, which have musical meaning and purpose, quite easily. And you heard what came out was quite, how would you put it, melodic. So I want to change this a bit. I'm going to have 4.times2. And I'm going to have 4.times2 again, actually. And up here, I'm going to use a random seed to reset my random seed. And once again, I keep on typing in 2, 3, 4, 6. Type in a randomly chosen number. And here I'm going to go, I'm not even going to bother with the tick now because I don't need it. I'm going to choose randomly. I'm going to use choose like I did before. And every time I go through here, I'm going to put an extra sleep 1. And do I have the right number of ends? No, I didn't. What this will do is it'll play a little 4-note melody, which will repeat 4 times because I reset the random seed and put a gap in between them. So being able to create these chords, etc., is interesting because I can do things with them. Here I'm just choosing notes from chords, but I don't need to do that at all. What I'm going to do is to get rid of this altogether and just play notes. And it gives me this major 7th chord. I'm going to go back to the default 1 octave. Okay, and I've got my plain notes here. Now, this isn't so interesting at the moment, but I'm going to put in a live loop and just show you how quite quickly we can come up with some interesting things. So, at my beginning of my live loop, I'm going to put a tick, play notes, and I'm going to go, and then a sleep for 4. Okay, so let's see what we get with that. It's not going to be that interesting because we've only got 1 chord there. Okay, if we had kicking drum loops, etc. playing along, then things would be much more interesting. Right, what I want to do is I want to say that chord is an interesting thing in itself. It's a ring buffer in itself, but we can have ring buffers of ring buffers. So I'm going to have a ring which starts with a chord like that. It's then going to have a chord and because notes is now, and this is getting complicated, a ring buffer which has 2 chords in it, if I go tick and play notes.look, which gets the current one, it should first go to the first one, then the second one, then go off the end, so it comes back to the first one, second one. We should get a rocking back and forth chord progression here. And of course, if I do come on. Oh, let's go off 90 to make it a little bit duller. Let's see what we get. I must admit, I can't remember how long the Amen loop is. We'll soon find out if it's playing way out of its pitch. Okay, that's enough for this movie. And what I'm going to do is I'm going to, next time, look into things a little bit further. And I'm going to look at scales and perhaps how we can use scales to do some interesting things. Okay.